All right, hello, this is Laura of Enerstructa, and welcome to our Zero Energy Homes Monday talk. Today we are going to discuss walls and high-performing walls and what that could look like. So it's kind of a fun topic. There's are a lot of options to achieve a more energy efficient and airtight wall. So I'm here in our garage and I'm just going to dive into a product that is pretty interesting from a cost-effective standpoint, at least here locally in the Columbia River Gorge, for builders to build better than a traditional wall. So I'll just actually go back a minute and just talk about what is common and standard in new construction. So typical new construction wall is a 2x6 stud with a half inch, or it's 7/16, whatever, the sheathing. It's about a half inch thick sheathing on it. And then it's filled with R21 insulation. Typically that's fiberglass. So that's what I am seeing for new construction here locally. And yeah, pretty typical. So that's code minimum. And to go above that, some states like California are starting to require exterior insulation on top of the sheathing, or you can do it underneath as well. There's a product made by Huber Woods called Zip R sheathing, and it actually integrates the foam into the sheathing, so it's all in one piece. So I'm just going to show you that real quick. Okay, so this is green outside. We'll talk about that in a minute. So this is the sheathing part. It's kind of like an OSB type product where it's different pieces of wood that are glued together, and then there's this piece has a half inch of polyiso foam on the back, so that's rated at, I believe it's 3.3 R value, so R 3.3. And this actually they make this panel with foam that's up to 2 inches currently, so you can get, I don't know the R value off the top of my head on that, but you can actually get this with more foam on the back. So I'm starting to see some builders here installing this system with the half inch foam on a lot of houses, so that helps you create a thermal break from your conductive heat losses going through the wall. So instead of just having wood studs and wood sheathing, that your wood's pretty conductive to heat flow, and that's why we insulate. So having the foam between the studs and the sheathing, or even on the outside, helps break that thermal bridge. And the other cool thing about this product is it has an integrated WRB, or water resistive barrier. So that's what this green coating is. So it's, instead of using like something like Tyvek or tar paper, that's already built in. And then where the panels come together, you end up taping the seams. So that's what these dashed lines are showing, is where the tape overlap needs to be. So this is a really interesting product. From what our local building material supplier has told me, is it's more cost effective to buy this all-in-one product from just even a material standpoint than to buy separate sheathing and foam, not to mention installation savings on time and labor costs. So I have a builder who says this, he thinks about it as far in terms of trips around the building, so this saves him a few trips by just installing this material. So this is something that if I were building a typical new construction house, I would definitely be using this type of product, because it just makes a lot of sense from a lot durability, long-term energy savings, adds a little bit more to the cost up front, but it's going to help the house be more comfortable and help the occupants save money over time. So now we're gonna go upstairs. So this is kind of the another high-performing wall assembly, and this is kind of taking it to more advanced level. So this is ICF construction, insulated concrete forms, and this is one of our window framing. I'm going to go up top and show you what the inside of the wall actually looks like. This is just residual concrete left over from the core that needs to get cleaned off. But this uses expanded polystyrene foam, and there's a core of concrete in the middle. So basically kind of where you do see concrete here, it's inside of there, but I'll show you up top. It uses concrete in the middle, and there's foam, 2.5 inches of foam on the inside and the outside. So it kind of offers a double thermal break, and also takes advantage of the thermal mass of the concrete to help the wall have a lower, or to take heat from going through the wall kind of at a slower rate. So there's the wall is actually 13 inches thick. So even with a wood framed wall, I'll go into that next, but a thicker wood framed wall would take longer for heat to transfer from inside to outside and outside to inside. So having the thermal mass provides a really good air tightness layer. So as long as we make sure when we install our windows that we seal around them really well, then we will have a very tight, efficient envelope. And that means that we can install a smaller mechanical system that we will not need to operate as much. So although this is one of the most expensive types of wall construction up front, in the long term, it will actually end up saving money in it's sort of like cause and effect. So it'll have longer term savings. So hopefully I'm explaining that clearly enough. I'm just gonna go upstairs. I keep getting distracted by wanting to show you the concrete. So I'll just show you that really quick. So that still kind of needs to actually get cleaned up a little bit more, but there's foam here, and then for 2.5 inches, and then concrete, and then another 2.5 inches of foam. So a lot of concrete. This is going to be our patio door opening, and we did not use the thermal bucks here, just for a few different reasons, but yeah, I can't even remember anymore. Just kind of, you can use them, you don't have to use them. Oh yeah, I remember, because we weren't quite sure what we were doing as far as our door was going to be. We want it to have solid wood, so we're going to have pressure treated wood against here because this is going to be a 6.0, 6.8 sort of sliding glass door. So we want to have something a little bit more structurally sound with that kind of attachment. So the thermal bucks, which are the foam, those actually have plastic connections in them that help you screw the screw wood frame and windows directly to them. Since we're doing an outside rain screen, which means we're gonna have a wood frame around the window with 1x4 or something, or 1/2-inch plywood. So we're going to do that around, well, this is the inside, but on the outside, just here. So you can actually directly attach, like screw into this part, 'cause there's, inside of the foam there is plastic webbing in there that you can screw into that will hold a window. But we are going to be creating an air gap between the foam and the siding so that when water gets behind there, because it always does, no matter how good it is, you can always get water, potential water through there. So we're going to create a pathway for any water that gets behind the siding to drain down. And also that helps reduce the pressure for like a normal house that has siding directly against the framing, that there's like a pressure drive with the like wind and pressure differences from inside to outside that can help drive water through the walls. So if you have a rain screen, so some kind of furring strips of wood with air gaps in between them behind the siding, then that can help your siding allow water to drain and for the siding to dry out. So especially if you're using, if you're using wood siding, that's really good to use because that way your wood will last longer. So other types of wall systems that are thicker wall systems. So we talked about the ICFs, and then then we talked about the the zip bar sheathing. So zip bar sheathing, you can put that on like a 2x6 stud cavity or stud wall, and then fill a cavity with insulation. You could also, I've seen some custom builds where they are shifting to using 2x8 studs for a thicker wall, or using a staggered stud system where you have maybe an 8-inch wall or 10 or 12-inch wall, and you use 2x4s. Like you basically build two walls. So you build a 2x4 wall that's on the inside face, and then a 2x4 wall on the outside face. And then there's maybe a few inches in between those two walls, and you have your drywall on the inside and your sheathing on the outside, and then you blow in insulation inside that whole cavity. So that's a better application for like a blown-in insulation versus a batt insulation. And blown-in insulation is generally better overall because it helps with the air tightness of the wall, and again, that's good because you don't want to have convective loops inside your wall that could be moving around moisture and air. So let's see. Let's just talk about different types of insulation real quick. So we talked about there's different types of foam. So the ICF blocks we used are expanded polystyrene, so like typical styrofoam things that for packaging. And then there's extruded polystyrene, so that is the blue or like pink board you see around, and that has an R value of 5 per inch. Typically the expanded has, like the ICF is R4 per inch. And then there's polyiso foam, which is what was on the backside of the zip bar sheathing, and that's generally around 6 or 7 per inch. So that's kind of some of the highest R value you can get. There's also spray foam that can be installed, and the high density foam is around 6 or 7 per inch, and the low density is around 4 per inch. And so the applications of spray foam are, you want the high density against any surfaces that are like concrete, that are going to be possibly wicking water, because that does not allow water and vapor to go through, versus the low density foam. Another application for the high density foam would be if we decided on our our vaulted ceiling, to not do any outside insulation, but to just fill the cavity with insulation, we would want to do, in this climate, at least 3 inches R20 of closed cell foam against the roof deck, and then we could fill the rest with a batt insulation or blown ins, just for more cost effective option. And then, so for batt insulation, typically you see fiberglass batts, and there's also one of my favorites is the rock wool insulation, or it used to be called rock sole, but now it's all rock wool, and that has some cool properties, like it is resistant to mold and mildew and insects, so they don't want to create homes in there. And also it has some fire resistive properties as well. I actually used that on my tiny house that I built, and it was actually also really great to install. It's not quite as bothersome to the skin as fiberglass batts are, and it's pretty easy for an owner builder to install themselves. So I think we might be using that in the cavity on top, in the ceiling and the walls, but we might also blow it in with either fiberglass, probably fiberglass. So between fiberglass and cellulose, fiberglass is a little bit higher R value per inch for blown in, and it's more stable over time, so it won't settle as much as cellulose will. Cellulose also can cause like possible mold and mold issues inside the walls if it does get wet inside of there, and also just sink over time. So it's really important, if you want to use cellulose and if you're a person that doesn't like fiberglass and you want cellulose in the house, then I'd really recommend making sure you hire someone who is really knowledgeable in installing that correctly, so it has the right wall density. And there are ways of calculating that they should know about, so definitely some questions to ask your installer. So yeah, blown in fiberglass, also known as bibs system. So that could be either fiberglass or cellulose, but typically fiberglass. So blown in fiberglass, blown in batts. And the way they do that is they build the wall, they frame it out, and they have the sheathing on the outside, and then they put netting on the inside of the wall, and then they dense pack the wall with a blower. So you can rent that kind of a system from places like Home Depot, but unless you really know how to do it correctly, it's really hard to achieve the right density and avoid settling over time. So I've done an energy assessment in a house where a homeowner had self-installed, blown in, and we could see with the infrared camera that it had settled over time. So it needed to get reblown, ideally. And there's some other cool insulations that people are exploring with, like just regular wool insulation, and also there's like mushroom insulation that people are exploring with, but they aren't very widespread yet. Oh, and also blue jean insulation too, but I don't really see a lot of that. There's not a very good availability of it, and not a lot of products out there. So yeah, I think that's it. So really the biggest takeaways for zero energy homes are that you want to have a well-sealed wall with some kind of insulation that creates a thermal break. So whether that is outside insulation, exterior insulation, also called outsulation, or you can have a double stud wall where you have your thermal break comes in between the two walls that are framed with the insulation. The whole cavity is filled, so in between the walls is the thermal break. Or like an ICF, it's kind of the same idea, where you have insulation on the inside and the outside with the concrete in the middle. So yeah, Okay, I think that's it for now. So we'll be back next week with a new topic and on Monday, and then join me Wednesday for another Healthy Homes and Home Performance topic, and Saturday for a DIY class for Mother's Day. Okay. All right. Take care. Bye.